Hi guys, so today we will be solving 5770. Hi guys, today we will be solving 5070 paper 2 variant 2 May June 2023. It's chemistry paper 2 theory, and the time duration for it is 1 hour and 45 minutes. So it's basically a total paper of the total marks for the paper are 80, and we have to answer all the questions. Okay, so let's begin with the question number 1. Okay, so the question is asking us that choose from the following oxides to answer the question. Okay, so this is the list of oxides we have. Each oxide may be used once, more than once, or not at all. Okay, so the first one is state which oxide is neutral. Okay, so neutral basically means neither acidic nor basic. So we know that H2O is the one, water. So we'll write H2. Okay. B reacts with calcium oxide to form slag in the blast furnace. We have studied that, so it is silicon dioxide. We have it here. Reacts with warm dilute hydrochloric acid to give a blue colored solution. Okay, so here we are given two details. That first, it reacts with warm dilute hydrochloric acid, which means it must be a basic oxide. And secondly, it gives us a blue colored solution, which means blue colored solution we have studied in our for ATP and for paper 1 and paper 2 as well, that uh copper gives us a blue colored solution when it's in aqueous state. So here we will look for copper, and we do have it here, copper oxide. So here I'll write copper oxide. And copper is a metallic oxide, which means it is basic and it will react with warm dilute hydrochloric acid. Okay. D is amphoteric. So amphoteric would be like aluminum, zinc, and we do have zinc here. Yeah. Here is zinc oxide. Okay, let me clear it. Part E contains an ion with an oxidation number of +3. So here I'll recommend you to first look for those which you haven't used yet. So we have used H2O. Let me just cancel it out, H2O. However, we can use it more than once but still I would suggest you to go for the one which you haven't uh, used. Okay, so silicon dioxide, zinc oxide, okay, copper oxide. So here it is, or let me just zoom it in so make it clear. So it's sorry, -2, oxygen is -2, it's +2. Here oxygen is -4. This combined divided by 2, so it's -2, but for finding it for carbon, we'll say it's +4. -2 +2 -2 +2. I've done it still. Here it is -6, and for balancing it we need +6. So here we have Fe2, and which means that we have two iron, sorry, yeah, 2 iron. So we'll divide the charge by 2, so it would be +3. So what we would write? We would write iron oxide. Iron oxide contains an ion with an oxidation number of +3. Yeah, it does have. It does contain. Okay, so here we will individually take one iron not like Fe2. It's for Fe2 it's +6. So do not just skip it over. It's Fe2 and it has +6. We will divide the charge by the we will divide the charge by the number of atoms the compound contains. Okay. Decolorizes acidified aqueous potassium magnet. We have also studied that in gas identification notes. So it is sulfur dioxide. Okay. So question number 1 is completed. Okay, so let's go to question number 2. Okay. Question number 2 says that group 7 includes the elements fluorine, chlorine, bromine, and iodine. Okay, chlorine is a green gas at room temperature and pressure. State the appearance of iodine at room temperature and pressure. So let me tell you one thing, that at room temperature and pressure, fluorine and chlorine are gases, bromine is liquid, and iodine is solid. So, this thing should be clear in your mind, that in which physical states do all these 4 elements uh, uh, exist at room temperature. So so we have been asked about state the appearance of iodine at room temperature and pressure. As I just told you earlier, that the physical state of iodine at room temperature and pressure is solid. So solid, we have to include solid indeed. Okay, so I'll just write solid here. Solid, but appearance also includes, no, its color. Okay, it also includes its color. Okay, so keep this thing in mind. Iodine is a kind of, you may say, a gray black solid. Okay, so we can say that it's a gray black solid. Chlorine is written already, green gas. Bromine is reddish brown or brown, you can say. Okay, so part B. Chlorine reacts with aqueous potassium iodide in a displacement reaction. Explain in terms of electrons why chlorine is an oxidizing agent in this reaction. So, one thing you have to keep in mind is that what oxidizing agent means. It does not mean the one which oxidizes. Okay, it doesn't mean that it oxidizes itself. It means it is the one which reduces itself and oxidizes the other. Let me write it for you. Oxidizing agent reduces itself and oxidizes others. Okay. So here they are asking that why chlorine is an oxidizing agent. So chlorine is here, and here it. So here we can see, let me zoom it in. Here we can see that as it is in its elemental form, so its oxidation state is 0. And here it becomes the overall charge is -1, and there are 2 ions, so it would become like for each chlorine it would be -1. So this means that chlorine gained electrons. So here they're asking us in terms of electrons, right? So we know that a reducing agent gains electrons, and an oxidizing, the one which is being reduced gain electrons, and the one which is being oxidized loses electrons. And here it is an oxidizing agent, which means it is being reduced, which further means that it will be gaining electrons. So we'll write that chlorine is gaining electrons. We write electrons because there are two chlorine atoms and more than one electron. Like each chlorine atom is gaining one electron, so it would be electrons. Okay, don't write one electron. Okay. Part two, we are being asked about the oxidation number of iodine. So it's in its elemental form, so it would be definitely zero. Okay, part three. Describe what is observed during the displacement reaction. So these are ions. We can't see them, there's no observation of ions. But for iodine is an aqueous form. So in aqueous form, iodine forms a brown solution. In solid, sorry, at room temperature, it's solid and is a it's a gray black solid. And in an aqueous state, it's a brown solution. And when iodine vapors are present, which is iodine is in gaseous state, so it has purple vapors. So keep that thing in mind. Okay, right. Okay, so let's move towards the next question. The rate of diffusion of fluorine gas is greater than that of chlorine gas under the same conditions of temperature and pressure. State what is meant by term diffusion. Well, these are like 3 marks. So we should write here that is the movement of particles from a region of higher concentration to lower concentration. Okay. All right. Explain why the rate of diffusion of fluorine is greater than that of chlorine under the same conditions. So for this question, I'll give you a simple, I'll suggest you a relationship, and using that, you can easily answer any such question which is, the same type. Yeah, let me tell you the relationship. But before suggesting the relationship, let me tell you one thing that here in part C, here we have been told that the rate of diffusion of fluorine gas is greater than that of chlorine gas under the same conditions, temperature and pressure. So here we can see that the conditions are same, but what is the difference? The difference is of the MR. So chlorine has an MR F2-19 to 30, and chlorine is 35.5 to 2 equals to 71. Okay. So here chlorine has a greater MR than F. So this relationship I wanted to tell you is about. Sorry for the disturbance in the background. Okay, so diffusion inversely proportional to the root of it. You don't need to know who suggested this relationship, but and you don't even need to mention it in your answer. You just need to, use this relationship to, extract uh which get if, for example, if a question was given that for example, fluorine and chlorine are two gases, and tell which one has a higher rate of. So how would you deduce it? You can use this relationship, all right. And for answering this question, we can say that fluorine is 38. Okay, so higher the MR, lower the difference, and vice versa. So here it means that fluorine has a lower MR. That is why its rate of diffusion is higher. So here we can say that fluorine has a lower MR, or it is a relative mass. Keep in mind that we don't have to write this relationship. We will just use it to deduce our answer. Fluorine has lower relative molecular mass. That is why its rate of diffusion is greater. Well, it's 1 mark question, so you don't need to write this answer. Or I guess you should write it. Rate of diffusion is higher. So, yeah. So last part is the rate of diffusion of fluorine increases as the temperature increases. Suggest why using ideas about kinetic particle theory. Okay. The rate of diffusion increases, the temperature increases because the kinetic energy of the molecules increases. You know that increase in the temperature causes the increase in kinetic energy. So we'll write as the temperature increases. So I hope you I hope I made I made these two questions clear to you. And if still you have any queries or questions, so you can tell me in the comments. And not forget to like, share, and subscribe. Thank you. State the oxidation number of aqueous iodine.